Hello, everybody. My name is Ivan, and this is our first day of our JavaScript Competency Center New Year week. So this is our fourth online conference, and we are really glad to see you here. And we hope that you will enjoy this event. Feel free to subscribe to our community on our community platform, to our YouTube channels, to do not miss anything, any new events. So this week we will have a couple of talks, and tomorrow you will be able to listen to talk about new AI technologies. On Wednesday we'll talk about accessibility challenges in React. On Thursday we'll talk about content platform and again challenges with working with that. And on Friday, we have, again, very interesting talk, and I'll just try to read the name of this talk because that's related to 2D and 3D graphics. So the name of the talk is How to Avoid a Disaster on a Project and How to Turn 2D Picture into 3D Application. So you might mention that I missed information about today's talk. So that's because we changed agenda a bit, and today we have a very interesting talk. And the name of this talk is Rust as a second language, as a second programming language. And we have a very interesting speaker. It's Stepan Sinduni, and he'll talk about Rust a bit. Hello, Stepan. Before you start, I'd like to do again a small announcement that the most interesting question will be rewarded. So, guys, if you have any question, feel free to ask them in any platform you're watching this conference, and we'll able to ask this question to Stepan, and he'll try to answer it. And again, the most interesting question, Stepan will be needed to choose that one, will be rewarded. So I think that's it from my side from the beginning. And Stepan, the floor is yours. Feel free to start.
Thank you, Ivan. Yep, as Ivan mentioned, my name is Stepan. Today we're going to talk about Rust. Before we begin, about your questions. Feel free to post your questions. I will check them maybe during the talk or at the end, but we will answer them at the end or offline later. And as Ivan mentioned, we will pick the most interesting question, and the winner will be rewarded. So now, why Rust? Like the hell you might say, like it's just CC week. We're talking about JavaScript frameworks, etc. But here I am with Rust. Well, first of all, you see, like it's got signed. Like the Rust was talk was on the Thursday, but we moved it to the Monday. It's because Rust is always first. It's the most famous, most loved programming language in the world. Yeah, there is some questions about work position, but keep your horses. I think we today will talk about this as well. And generally, I would like to talk today like how Rust, some of its most famous features, and how it actually these features can benefit you as a web developer. Okay, you might say, why do I need another programming language? I know JavaScript, I can do what I can do with JavaScript, pretty much anything, right? I can do front end, back end. This scripting language used even in, as far as I know, in data science sometimes. Yeah, I might agree with you on this, but while JavaScript is great to start to like kind of have a look into, for example, backend development, it's not that great. It has its flaws. First of all, it's because it's on time, just-in-time compilation language. As you can see, there's lots of weirdness which you might see in your programming production code. So you can say that we have TypeScript, which kind of addresses this and fixes most of its issues. And again, I agree with you, but at the end, it's the same JavaScript. So you miss a lot of static compiled languages. Like now when I tried Rust for a couple of months, I see the difference, and that's actually a huge gap. Yeah, so let's talk more about why another language. So as you know, I can give you like example. For example, I'm Ukrainian, I speak Ukrainian language, and I tend to shape my thoughts in particular way. in the way I used to speak, I used to communicate with my friends, colleagues. And when I switched to English, I use different phrases, different slangs, different words. And I also noticed that I even think differently. Like my my way of thinking is different. The same applies to programming languages. Like you have different, for example, like you can have few different languages and they approach the same problem in different way. And the more ways you know, like the more uh, approaches you know how to solve the problem, well, the more proficient you are, and kind of you have more kind of value because you know more. And I hope I got you a little bit excited with all this info, why we're going to talk today about different language. Again, my name is Stepan. I'm Associate Chief Software Engineer at EPAM Systems. And today I want to show you all the cool features. Well, actually not all because we have a small talk, but the most like famous feature, I think, which I liked in the Rust, which I hope will make you excited about the language as well. So we're going to talk about billion-dollar mistake. If you don't know this, no worries. We also talk about that. We'll look at error handling at Rust, what is borrow checker, and also how to mix references. And it's one of my favorite. It's mutable foot guns. That's actually a cool feature of Rust. How it can prevent you from doing stupid things. Yeah, again, before we go any further, like let's talk a bit what can you do with Rust. So you can do pretty much again anything, even though Rust is system language, like it's kind of on the same level with C, and it's often referred as C killer. But you can do even web with Rust. I tried this. I don't recommend that, but it can have its use case for some backend development when you need pretty fast and safe API. Yeah, so first one is Linux. So Rust made its way into the Linux kernel. It's not like there is a lot of it, but it's used in some bindings. And it really says a lot because, as you know, Linux developed only using C, not even C++. Also, like recent news from Microsoft that Microsoft is going to found languages like Rust. I don't know what that actually means. Is they going to kind of found Rust, or we going to see Rust Sharp or something like that in the future? I hope they going to stick with Rust and don't invent their own wheel. But this also will help this also shows the adoption of the industry. Another tool which you might use is FNM. If you work with Node and you need to switch versions, you know the analog of this tool called NVM, Node Version Manager. I use this FNM. It's better and pretty much a lot faster than NVM. And by the way, out the box, it supports version switching. So after I installed this, I completely forgot. Like I even don't need to switch version because it does automatically. Another thing is Dino. So if you don't know, Dino is kind of like a second child of Ryan Doll, and Ryan Doll is Node.js developer, like not developer. He created Node.js, and after that he created Dino, and Dino is meant to be like kind of better version of Node.js. And I must say you that even though Dino is not that popular, but it made like given that Node.js now has a concurrent, sorry, I don't know, maybe not that word, but even though it has like different analog, it helps Node.js to develop its feature. Dino has its influence on Node.js as well. Another thing is Alacrity. It's really fast terminal emulator. It's also written in Rust. Stackship, I also use this. It's a great customization prompt. It makes your prompt look really nice. Tori, it's like if you worked with Electron, it's analog of Electron, but it meant to be much faster. For example, VS Code is written using Electron, so you can install it using desktop app. Tori is the same thing, but written in Rust. And of course, Tree-Seater. Tree-Seater is a really fast parsing library for it parses everything into abstract syntax tree using Rust, and it's really fast. Okay, now let's talk about $1 billion mistake. So, and I have a question to you. Like, do you know what it is? Let's check chat. Can you write down what is $1 million mistake? If we have anything. Mm-hmm. Okay, it's either we have a gap or nobody knows what a $1 billion mistake is. Yeah, we have null. Yeah, so that about remainder of pennies. No. Okay, we have actually an answer, and this is correct one. It's null. It's actually null. Yeah, invention of a null pointer. It was invented by this guy Tony. And why it's $1 billion mistake? Because it causes so much trouble that business it cost a lot of money to the business. And it's kind of the null pointer reference. So it's when you try to reference a fragment of memory, but nothing there. It was already cleaned up. And if as far as you know, in JavaScript we actually have not only one but two these mistakes. And if we look even deeper, undefined actually under the hood has also different kinds of it. So how actually Rust is going to fix this? Well, it uses pretty much familiar concept for at least for TypeScript developer called enum. For those who don't have experience with TypeScript, I will tell you a bit. Enum is enumeration. That means that you can have only two instances of this value, and a difference with. Let me just use the mark laser pointer. Yeah, you should see the laser pointer here. So it also uses generic. So in Rust, enums is powerful. They can even hold a value compared to TypeScript because, well, enum is not a real thing in JavaScript. Let's look at example. Let's create a new function. Call it like we will try to divide two numbers. So f64 is a float 64 number. So you can think of this as just a floating number, and we're going to return an option of float 64. And we check if we try to divide by 0, we return none. But in other case, we return some and we try to divide this thing. Notice that I don't need to explicitly type return here. That's because the last expression of the function in Rust is return, and we don't have a semicolon here. It means it's expression. So how are we going to use this? Easy. We just call this function. We write the result into the variable. The variable is declared using let keyword. And we use this match expression. So match is, you can think of this kind of switch on boosters. It's really powerful concept. And as you can see, we can, let's see first none. So we can see if the instance of this result is none, the return value, we will print line. Print line is kind of console log, cannot divide by 0. And if it's sum, we can also extract the value of the sum and put it into X variable, and also going to print this. Yeah, so I'm not going to run this because yeah, it's pretty much simple. But what the interesting thing, what you can do with it is notice this question mark. It's not optional chaining or something like that. It's kind of feature of Rust which allows kind of early return. So once Rust see that the return type of this function is none, it will end the execution of this function and return back to the caller. So in this case, for example, as you can see, I don't even need to match the result. I can explicitly immediately access the value here, and it will be 3 here. And also, if we try to divide by 0, remember, we will get none. So it actually won't be printed because we will return early and write the value of this function into this wrapper result. Yeah, so I also need to then return this sum and braces. So this braces in Rust is kind of void in TypeScript. It doesn't mean anything. It just means that the return of this the return type of this function is not going to be used. And if I try to run this, you can see we have divided by 3, and we have a log from main function. Pretty much simple. So as we can sum up it by saying that Rust doesn't have this mistake, like a $1 billion mistake, because it doesn't have a concept of null at all. Instead, it uses option. Yeah, so before we proceed to the next topic, I want you to pay attention to this JavaScript function and tell me, like, again, in the chat, how do you think, what is wrong with this piece of code? We're just going to kind of fetch some data, we transform it to JSON, and we return. It doesn't matter where and how we use this function. It just, if you look at the body of this function, do you spot anything dangerous? No catch. Okay. Function and async keyword are switched. No. Okay, so Peter was close. It's like, yeah, not that we don't have no catch here, but it's actually error handling. We have few, like, we don't have any annotations that any of that pieces can throw an error. And for maybe for experienced programmers, it's not an issue, but you still can forget to handle the error there. So Rust uses a similar concept as option, but now it has a different name. It's called result, and we have two generic variables here. So we have OK of t and error of e. So let's look how it's used. Let's refactor the function. We will introduce a new enum, which will represent all the error. For now, it's going to be just simply 1. And what changed is we changed the return type. Now we say that in case of success, we will have a floating point number. And in case of error, we will have error of the instance of this enum. And now we return, instead of none, we return this kind of error. And if everything is OK, we will return the instance of OK. Let's see the usage, and it's actually similar, but now we can have, like, we also use match expression to extract the result and an error. But it gets pretty much even better, like, because with option, we could use question mark, and we can do the same with result. Now notice that I don't even need another wrapper function. I can do it in the main. This is because main is special function in Rust. And if it sees the result and it returns an error, main will kind of end the execution of the program and will present the error. So it's like kind of, I don't know, process exit, something like that, but with error. And we also add question mark here and add question mark here, like when we try to divide by 0. And if we try to run this, we see that first division is successful, but the second one, like, we didn't reach this print statement, and we immediately got to the kind of program execute. The program was halted. And if you're familiar with functional programming, those concepts might be really familiar to you. And that's because a result and option is kind of monads. So they can have, like, kind of left and right values. And this question mark is, if I'm not mistaken, it's something like do notation, something like that. So as you can see, it helps us unwrap the value and work with the value here. But in case we have kind of this is probably right or something like that, in case we have error, it will kind of propagate the error back to the caller, and we can handle the error there. And also those two instances, Rust result and options, they have a useful method to work with. Like you can call is_org, you can transform between those instances, and also you can map them. Okay, now let's talk about borrow checker. So what we have here, we have a simple function where we're going to look through array of numbers and print them to console. We'll also define this array 1 to 3, and we'll call it 2 times. Okay. And what we can see is, well, nothing excited here. We got 1 to 3, 1 to 3. Okay, let's try to do the same in Rust. So we define the same function. We say that we are going to accept vector of i32. Vector is the same as array in JavaScript, and i32 is the same number, but not floating point number, just a regular number. So we also define a vector. The vector defined in Rust in the following way, and we try to call it 2 times. How do you think? What will happen? We will get an error. Let's go through it. So it says use of moved value array. Okay, doesn't make sense right now. Move occurs array has type because array has type vector, which does not implement the copy trait. Kind of nonsense right now, but here it gets more interesting. Like we have value moved here and value used here after the move, and it even suggests us some hints how can we fix this error. So what is actually happening? Let me explain it to you. So Rust doesn't have a garbage collector compared to languages like JavaScript, Java, but it doesn't kind of have a manual memory management either, like C. Instead, it uses the concept somewhere in the middle. It uses the concept of borrow checker, and what it means is that each value in Rust can have one owner. So in case of this vector, the owner is this array, and when we call the function first time, the ownership of this value will be moved to this variable, and it also says that once owner goes out of the scope is kind of curly braces. So once owner goes out of the scope, the value will be collected from memory. It will be cleaned up. So in our case, when we try to call this function, we transfer ownership to the first execution, the function ends, and now when we try to call it second time, Rust doesn't allow us to do that because the value in the memory was cleaned up. So it doesn't allow us to kind of have this null pointer exception, something like that. So how can we fix this? We can fix this by using references. So this %, it means that I do not take ownership of this value of this array, of this vector, but rather I read a reference to it. So reference is kind of how I can say is that the value is there somewhere in the memory, somewhere in the heap, and I just need the reference to the location of that memory. And we can pass the value also by reference. So now if we try to run this, everything works fine because we have 1 to 3, 1 to 3, and the value will be collected once the main function ends. Now you know what is reference. Let's talk about what will happen if you mix them. Let me explain with example. So in JavaScript, we have a class, for example, foo, and we have 3 items in the array. We grab the last item and we pop this array and remove the last item in the array, and we print this last item. I won't be running this because you know that we will get this item, the last one, in the console, even though we removed it from array. But let's look in the Rust, how Rust does this. So it does not have a concept of class. Instead, it has struct, short for structure. Don't mind this derive. It's just so we can print it to the console. So we define our struct foo, also declare our vector with 3 instances of this foo. Notice that we even in Rust have a convenience method to get the last item. And we have the same method like in JavaScript to remove last item from the array. And we try to print this item to the console. And if I try to run this code, as you can see, I get another error. So it says, I cannot borrow items as mutable as it's not declared as mutable. So in Rust, there are two types of references, mutable and immutable. And here we try to kind of call pop method, which will mutate the value, mutate the vector, but we haven't said that item is mutable. So we need to add this keyword. In Rust, everything by default is immutable compared to JavaScript, where actually everything is mutable. And if you want to mutate something, you need to explicitly say so. So let's try it. We added this mute keyword. Let's try to run it, and we get another error. As you can see, like Rust is, you can get pretty much emotionally bruised with Rust while developing in it. It's because the compiler is pretty strict. It will fight you, hit you with lots of errors. But at the same time, it's better to fight those errors, fight borrow checker, and know that your program is safe. So it says that cannot borrow item as mutable because it is also borrowed as immutable. It says that this last, it's immutable borrow, and pop is mutable, and then we try to use our immutable borrow. So what it means is Rust has several rules about that. So first one is you can have like any amount of immutable references. That's because it's safe to read those values even in several threads. But at the same time, like you can use only one mutable. Like not in the same time. You can have either lots of immutable reference or just one mutable, and that's because if you have immutable reference, you expect the value to don't change, but mutable reference can do that, and Rust does not allow you to do that. So in order to fix the current issue, we can simply swap this line, and now we can run our program. How this works is that Rust sees that we have immutable reference here, and we use it only on this line 4. And after that, we don't have any reference to immutable references, so it's safe to kind of mutate the value now. And notice that the return value is not the foo, but rather the sum. It means that last method, it can return none, meaning that we don't have anything in the vectors. The vector is empty. And the last topic for today is mutable foot guns. So let's see at JavaScript. Let's define some array, one like without unordered with unordered items. Let's define a function sort. Let's call this sort and return this new array. And we try to sort this. And if we run the program, we will see that both value was sorted, original and sorted. That's because JavaScript, as you know, sort method, it does not return a new array, it mutates in place. And if you're experienced programmer, you know that, and you know that there is other methods which can do that. But if you're newbie, just coming to this language, it can be kind of unexpected. But Rust fixes even this. Let's define the same behavior in Rust. Let's define function sort, accept a reference to vector, and also we will return new vector. Notice we don't have any reference here. It means that we're going to return a new vector. So we try to sort and write the result into new variable and return this new variable. I just want to be explicit here. Also define new vector. Yeah, we will have 1, 2, 3. It's sorted here, like don't find this. And we call sort with passing the reference. And well, you might guess it, we get another error. That's because it says that this function sort expect to return a vector, but instead it returns this unit, nothing, void. Like, why is that? Well, it's because if we look at the signature sort method, it accepts a mutable reference to self. Self is kind of this. in Rust, but we don't have any return signature here. It means that, so in Rust by default, if function does not have a return signature, it means that function returns this unit, nothing. It wants to be explicit about what you return. So let's fix this. So we will add, like we will define our new array as mutable. Well, because if we want, this sort will throw another error. Remember that sort mutates. And we clone the value. Cloning is means simply like, it means what it means. It just creates another copy of this array, of this vector, and we sort it in place and return. So here we have 153 and calling this function and printing the result to the console. And as you can see, our sorted was sorted, but original was untouched. Just silly example of this, but you can see that by throwing some errors like that, Rust can prevent you from doing something you are not aware of. So as a summary, like after we looked at all this feature, let's agree that JavaScript is not that great, right? Well, actually, I'm joking. JavaScript is a great language, but it has its use cases. And we today talked about Rust in terms of its features. So we do not want to compare those two languages, like were they good, were they bad. Instead, my main like kind of topic to you here is don't stick to one language, explore different one. I showed you here like example of Rust and how learning it and exploring its feature kind of helps you to expand your horizons of the programming. And well, like, as I said, JavaScript is scripting language and it's meant to be easy. It does not meant to be robust. Like you want to do stuff easy with it, and that's why we have like it is so popular. And if you talk about Rust, like the idea behind the Rust is to fix a lot of issues which C language caused. Well, it's not just C language, but to fix a lot of issues with kind of prevent programmers from shooting yourself in the foot. That's why you will fight borrow checker a lot, but you will get a robust program in Rust. And when you're going to pick your language, I just want you to advise that pick the language which will actually help you think differently, will help you look at the problem in from different angles, from different perspective. And yeah, that was it from my side. Thank you. Check out our KB page, and I hope you enjoyed this talk. Let's look at the questions. I hope we have some
Thank you.
time.
Yeah, thank you, Stepan, very much. It was really interesting to listen to your talk. And yes, we do have a couple of questions, and let me read them. So the question is Rust as a second programming language, but what if Rust was the first one? What should be the second one?
So if Rust is your first programming language, you should be like kudos to you, but it's really hard. I would say it's the same if you would learn C, but C allows you to make more mistakes, whereas Rust will simply kill you. Like you will be pretty disappointed. So if you, I would suggest like to go with another language as first language because it's even hard to get a job at Rust. I'm not talking about even being a junior in Rust. And what should be the second? If you learn Rust, I think it's not that hard to like you will. It will be easy to learn another language, and I would suggest go with C.
Or
Okay.
TypeScript and JavaScript? It's better for
Probably,
the like
yeah. If you want
this
to do
engineers.
Yeah, if you want to do front end, go with JavaScript, TypeScript. But if you want to do backend, I would suggest go with Go.
Okay, yeah, thank you for the answer. The next question is from Peter Kiss. I know Rust made its way into Linux kernel. Do you think it would be replace large part of the implementation at a point?
Hmm. Well, yeah. So I know that it now uses some bindings, but I don't think it will be completely rewritten into Rust. So I want to here refer to again to Ryan Dahl, which says, like, it's the guy who created Node.js and Dino. He says that new projects should not be started with C but with Rust by default. So I think like we will see a lot of new projects written in Rust, but to refactor the old one, I'm not sure. Like pretty much we may see like different implementations, something like that.
Mhm.
But
Okay.
even with C, it's actually possible to, and with Rust, it's also possible to mix these languages. So you can have ABI in one language, which will call function in another language. So Rust is also has unsafe concept where it allows you to call kind of different API, like kind of functions from different languages.
Yeah, yeah, you're right. Okay, the next question from Milad. What side effect is println?
Mm, sorry, I'm not sure I got it.
To be honest, me
What
too.
side effect is print line? So print line is just printing to the console.
But
It's
this side effect means that something will be happened outside of the function.
yeah. So you see, print line, it accepts a immutable reference. That's why we got this error in that example, because we tried to print to the print line, but printing to the console is actually a sync operation. Like although we accept use it as sync, it's actually under the hood it's a sync, and probably that's why it doesn't allow us to do that. And also don't forget that once we like kind of read the value, we also mutated that, so we like don't accept like don't expect this value to change. So
Mhm,
Rust pretty strict about that.
Okay. And the next and the last question for today is from Thomas. Uh, okay, I mean that in GS, the function async my function syntax is not valid because it should be async function my function. Am I mistaken? Can you show the question? Yeah. Um,
Function async my fun is not valid because it should be async fun. Ah, okay,
Probably.
okay. Yeah, that was not about the syntax. It was about more concept. Yeah, if there's mistake, probably I didn't run that example. Sorry.
Mhm.
Probably that was.
Yeah, real developers doesn't test
Yeah,
their code; they just write it and send to test and to production.
yeah.
Okay, that was the last question from our. Okay, the last one. I see one more is from Grigory. Can we use Rust in web programming?
Yeah, of course we can. There is frameworks. For example, if you want to develop backend, there is for frameworks like Rocket, Actis Web, something like that. I tried it. It looks good, and you can also develop a front end using WebAssembly binding. There is let me just think. So there is a U framework. I tried it, but not sure I like it. It's hard. It uses the same concept as React, so it also renders itself. Uses virtual DOM, but I now trying to use want to try Leptos. It uses signals, and from the documentation examples, it looks much cleaner to me. So I will try that as well.
Mhm.
But even though I tried it, I don't recommend because it's really hard. Like the
It's easier to
development.
use React or even plain HTML and JavaScript.
Yeah,
It's really good.
the
Okay.
developers. Yeah, and I see we have more questions, or but I'm not sure we have time to answer all of them. Maybe offline.
Yeah, probably we'll do it offline. Okay, regarding the most interesting question, so all questions that we've heard and that you've seen probably, can you choose the most interesting for you?
Uh, yeah, I think I can do this offline, right? Because I need to read. Like we have not only these three questions,
Mhm.
we have more.
Okay, yeah, we'll do it offline, but guys, please provide some your like make sure that your profile in whatever platform you use to the comment has information for us to contact you. So that was it from our side. We are a little bit run out of time, but thank you guys for watching this really interesting talk about Rust. And yeah, a couple of like quick announcements. Stepan, he's our graduator of our public speaking schools. You can like decide if it was good or not. Yeah, probably we did something great by using this school, and Stepan got some skills. And another thing is, yeah, tomorrow we'll have the next talk. It's going to be about artificial intelligence. Feel free to register and watch it. So I think it will be really interesting. Thank you very much and have a good day.
See ya.